see the unseen, change the unchanged. The innovation.
Hi, I'm geophysicist Ross Mitchell, and welcome to the video highlights of Volume 3, Issue 6 of The Innovation. The Innovation is clever to collaborate with professional artists for their eye-catching covers, and the cover of this issue makes that advantage bravely clear. The sun not only breathes all life, it also brings inexhaustible clean energy to the earth. The constraints of traditional centralized photovoltaic energy production are being overcome one by one. In this issue of The Innovation, we feature advances in flexible perovskite solar cells. From spacecraft and curved photovoltaics to wearable devices and IoT sensors, opportunities abound. Combining forces of climate variability. When it comes to drivers of Earth's climate on timescales longer than our lives, the ice ages may come to mind. These cycles on the order of tens to hundreds of thousands of years are driven most fundamentally by variations in Earth's astronomical rotation. They are called Milankovic Cycles, after the scientist who hypothesized of their existence before we had the evidence to prove it. Abundant evidence to support Milankovic's theory has since been found, and its three cycles of precession, obliquity, and eccentricity occur at periods of 20, 40, and 100,000 years, respectively. But despite Milankovic cycles having become consensus, nagging questions still linger. The basic idea has been that incoming solar radiation, called insolation, will vary depending on the three Milankovic cycles that affect Earth's wobble, tilt, and orbital shape. As the amount of insolation reaching Earth's surface varies, ice ages will come and go. Traditional Milankovic theory therefore focused on the waxing and waning of polar ice caps, like in Greenland and Antarctica. But there are other systems other than high-latitude ice that can be sensitive to Milankovic cycles. This issue of The Innovation includes a comprehensive and innovative review seeking to resolve some deficiencies of traditional thinking by looking beyond simply changes in ice volume. Everyone has heard of or been affected by the monsoon. But when they say monsoon, climate scientists aren't just referring to the rainy season in Southeast Asia. Although there is a rainy season, there is also a dry phase of a monsoon. And there are also other well-known monsoon systems in South America and West Africa and all over the world, in fact. The monsoon is a low-latitude phenomenon, so quite different from, but complementary to, the variations in polar ice caps typically thought to express Milankovic cycles. The review in this issue of The Innovation suggests that variations in insolation due to Milankovic cycles are expressed in both high-latitude and low-latitude climate systems. They suggest the mighty monsoon may be the missing piece in the puzzle of Milankovic theory. The Mantle's Great Balancing Act. Next, a personal favorite of mine in this issue of The Innovation is my own commentary with international co-authors from the US, UK, and Canada. You may have heard that underneath Earth's tectonic plates, Earth's mantle is convecting. The mantle is the thickest layer of the planet. It is also the connection between the core and the crust. It is therefore critical to understand Earth's mantle, but challenging to do so given its great depth. All of you will be familiar with convection. In the atmosphere, forming clouds, in the ocean, causing circulation, and in our ovens, cooking our favorite foods. Although convection is a common principle, its behavior can vary from system to system. We typically think of convection as balanced. What goes up must come down. Or is it what goes down must come up? The truth is, it depends. Convection can be asymmetric, being either dominated by upwelling, called bottom-up convection, or dominated by downwelling, called top-down convection. So what about convection in Earth's mantle? The truth is, once again, it depends. Evidence for both options exists, But both options also have their problems. Some geologists doubt the depths and even the existence of mantle plumes, the upwellings. Other geologists doubt the existence of early Earth, of subducting slabs, the downwellings. In this issue of The Innovation, my co-authors and I found a series of 3 rock types through time that we argue reflect the evolution of different styles of mantle convection. Not only are the 3 rock types useful, they also happen to be beautiful. The first rock type, called komatiites, only really existed during early Earth history and have become very scarce ever since. Komatiites formed from the hottest magmas ever generated by the mantle, so a connection to hot mantle plumes is expected. In contrast with ancient komatiites are kimberlites, which have only become abundant relatively recent geologic time. Kimberlites famously host diamonds, which indicate the importance of tectonic forces in plucking these precious gems that only form at the great depths of continents. A third rock type, called anorthosites, were abundant only during Earth's Middle Age, and nicely fill the gap between the disappearance of komatiites and the appearance of kimberlites. Sparkling anorthosite, rich in the mineral plagioclase, is why the moon shines so bright, and such rocks form neither by the dominance of plumes or tectonics, but something in between. The sequence of rocks is like a relay race, from komatiites to anorthosites to kimberlites. Based on how these rocks form and their relative order, we argue that the style of mantle convection has evolved over time, from bottom up to top down, and was balanced in between. But that's not all. In this issue of The Innovation, there are many other topics covered that we haven't discussed in the video highlights. Make sure to check them out. Topics include reaching sustainable development goals using science and technology, bioassay development for public health emergency, the future of remote sensing archaeology, protecting pregnancy and perinatal health in China, reaching sustainable development goals using bamboo and palms. China unveils its first anti-COVID-19 drug, and details about how inhalable antibodies can treat COVID-19. New international agreement for forests to fight global warming. Tibetan antelope migration to avoid parasites. Rethinking transportation for sustainable societies. Snake robots. Zoo of silicon-based quantum bits. Understanding the universe from the Daya Bay experiment. Agrophotovoltaics save the climate and fight poverty. Neural circuits underlying Parkinson's disease. Herb genomics. Palladium to the rescue. Cell traction forces technology. Flexible perovskite solar cells. Antibodies for yellow fever virus. CRISPR-Cas mitochondrial genome editing. Efficient propane separation. Spin-orbit-free antiferromagnetic semimetals. A new study on survival after cancer diagnosis. Inorganic semiconductors with metal-like behavior. Air pollution and human health in China. The marriage of zines and hydrogels. Fabric computing. Single-cell technologies. Now get to reading about the innovations in this issue of The Innovation.
Pursue excellence.